What we're looking at here is a PID control loop that we've set up in the DeltaV DCS system with split range outputs. Single analog input channel, single PID block, driving 2 analog output channels. Each one of those has its own separate cable running to a separate valve, and those valves are being split ranged. The purpose of the video is to show you how the split range block works right here, the splitter. This is a pretty interesting little function. And the way this works is it takes in the signal from the PID block directly, and then generates 2 output signals, one going to the first analog channel, the other going to the second analog channel. The other wires you see here are the back calculation values coming back around, letting the splitter block and the PID block know whether or not the successive blocks have been able to achieve their final values. We had a problem with this the last time we tried setting this up. We had the splitter block set up for what's called a complementary valve sequencing. So as one valve opens, the other one closed. We tried running it, and what we found is when we clicked on online up here and took a look at the actual numerical values, we were getting a signal of 40% to our first analog channel, as you see right here. We should have been getting a 60% signal to the second channel, but we weren't, because the second channel physically had an open circuit. The analog card detected that. It sent a back calculation value of 0 saying, hey, DeltaV, we don't actually have any current here. That signal came back around and said, all right, I'm not even going to try to tell you to go to 60 because I'm not seeing any sign that you're actually making it up to 60%. And that was the problem we had last time. We got it hooked up properly to the valve now, and everything now works. But I wanted to show you in more detail, now we've got everything done, how this splitter block functions. To do this, to test it, I'm going to go into the PID block and use my parameters over here to manually set the output. So right here, I see an output parameter of 60%. It's already in manual mode. I can force it right here from the Control Studio screen to go to whatever output I want. So if I go to 50%, whoops, double click, I'll go to 50% and click OK. Notice what that does. It forces that to 50%. That comes into our split range block, and we have 50 going to one valve and 50 to another. So right now in the middle, both valves should be in mid position. If I take this PID block again and go to an output value of 0%, what do you think should happen? 0 and 100, exactly. One valve ought to go to 0, the other one ought to go to 100.
Yep.
And there we go. The output 1 goes all the way to 100, the output 2 goes to 0. Recall that our output 1 was the reverse acting valve. If I take the PID block and make the output go to 100, what do you think will happen there? That'd be 0, and that's 100. They're complementary. And if I go to this, let's say, whoops, let's go to, whoops, try this, output. Let's say I go to 25%. What do you think will happen?
75.
75 and
25.
25. There we go. 25% out gets turned into 75 and 25. It's working like it should.
Cool.
So just to review what we did last time with our splitter block, I'm going to click once on that block, look at its parameters. And here, the way this works is sets up an array of input values and output values for the 2 channels. So looking at the input array, what we have here, the first 2 rows in this array are the starting and ending input values for channel 1. The next 2 rows in the array are the starting and ending input values for channel 2. So in both cases, channel 1 and channel 2 in the splitter block, it's accepting a 0 to 100% signal coming in from our PID controller. That much is very straightforward. If we go to the output array right here, we see what the outputs do. So for rows 1 and 2, it goes from 100 to 0. That's channel 1 going from 100 to 0. So I honestly wish they had the in array and the out array sitting next to each other so you can see this more easily. But as the signal goes from 0 to 100%, channel 1 goes from 100% to 0. That's what makes channel 1 backwards, a reverse acting. Channel 2, rows 3 and 4, as the signal goes from 0 to 100%, the output goes from 0 to 100%, so it's direct acting. We can do all kinds of interesting split ranging with a combination of those input and output array values that we type in. We've chosen to do complementary. As one valve opens, the other one closes. And again, we chose to do it here in the DeltaV system because our positioner did not support reverse action. We needed a special cam, and we don't have that available. So we decided to do it electronically here instead. It's one of our options. Are there any questions on split ranging? Okay, so it works. I'm happy with it. We've already downloaded this. It should be ready to run.